Hi, and welcome to this clip going through an applied multiple choice question which requires you to be able to recognize the subtleties of seeing what an oxidizing and reducing agent is in a redox reaction. So a little bit of background first of all. An oxidizing agent is anything which causes another species to become oxidized, and it does this by removing electrons from it. So anything that's oxidized as a result will have its oxidation number increase. In contrast, a reducing agent is a species which causes another species to be reduced by donating or giving electrons to it. So anything that's reduced in this way will have its oxidation number decrease. This is our question you need to think about. So it asks you, in which of the following reactions is sulfuric 4 acid H2SO3 acting as an oxidizing agent? So remembering what we've just mentioned, first of all, it means it has to be a redox reaction. So thinking about the oxidation number rules, H and O are likely to stay as +1 and -2 respectively. So we're really looking at sulfur. So the sulfur is in the oxidation state +4 in sulfuric 4 acid. So if H2SO3 is acting as an oxidizing agent, then sulfur will be reduced and this number 4 will go down. So +4, that is. So this is the technique we need to apply to each of the 4 equations. So we first of all have to assign oxidation numbers to all the elements, whether they're in compounds or they're uncombined. Then we can ignore anything which doesn't change oxidation number because that's obviously not part of the redox aspect of the reaction. And then finally, if we do have a redox reaction, we look out for what happens to sulfur. Is it going from +4 down to a smaller number, like +3, +2, a negative number even? So let's take A first of all. So assigning the oxidation numbers, we can think about this for a moment because sometimes there's a bit of a shortcut. So I'm actually going to show you the shortcut instead. If you look at H2SO3 and HSO3 minus, and if you break those two sulfur-containing species into their ions, you'll see that SO3 2 minus doesn't change. So that means the sulfur-containing species will not change any oxidation numbers, either in the oxygen or the sulfur. So this is a way round having to do all of that for this particular answer. It doesn't mean you can do it for all of them, but it's just something to watch out for. If you see SO3 staying the same, then that means nothing's changing in terms of oxidation numbers because sulfur is still bonded to 3 oxygen atoms, meaning it's -2 times 3 makes -6. So you can therefore from that work out that the sulfur hasn't changed oxidation number. If it's in the same species as it was before, nothing is altered. So the next thing to do is to look at B. So the same thing again, assign all the oxidation numbers, and then ignoring anything which doesn't change oxidation number. Well, you can see straight away that the sulfur doesn't change in oxidation number either up or down. So this isn't actually necessarily a redox reaction. It looks more like a decomposition actually. So H2SO3 just breaking up into SO2 and H2O. So that eliminates that one. Let's look at C. So this one's a bit more complicated. So if we combine all the put all the oxidation numbers in, I'm just going to quickly take you through what's happening with iron. So chlorine is going to be -1. This isn't one of the exceptions where chlorine takes another oxidation number. Iron is going to be in the +3 form here and the +2 form here. So therefore, we can look at what happens to the changes in oxidation numbers. So iron is involved. But what's happening to the sulfur? Well, if you look carefully, +4 will look to +6, and the iron, in fact, is being reduced. It's going from +3 to +2. It's going down in oxidation number, like we said earlier. So if we now think about anything happening to sulfur, it's not this one either. It's a more subtle reason, though. And if we do a little bit of working, you can see why. So the sulfur is actually being oxidized. So that means, in that case, it must be being acting as a reducing agent. We want it to act as an oxidizing agent. So this is not doing what we want either. Okay, so by process of elimination, we can see that it's D. Let's take a moment to think about why that is. It's one thing saying, great, let's just put down D and move on to the next question. But we're not in a test situation right now, so let's have a look at the logic behind this. So if we do the same thing as before, you might notice I haven't bothered to just assign all the oxidation numbers because by now, hopefully you're seeing what's happening. Hydrogen will be +1, oxygen being -2, and so on and so forth. Now this is quite an interesting one. So the sulfur is +4 on the left and it's 0 on the right. So H2SO3 is acting as an oxidizing agent, so this is why this is our correct answer. Sulfur has reduced from +4 in H2SO3 to 0 in sulfur as an element. So it's doing all this, it'll be reduced and its number will be going down. So the H2S, this species here, is oxidized as the S in that species goes from -2 down to 0 over here. Okay, hopefully this has been a useful look at this type of question. It was quite a tricky one, and unfortunately the correct answer was the final answer, so we did actually have to put in the time to work through all the others first. So with this type of question, where D happens to be the correct answer, and you have to do some working to get there, it's going to be a bit of a time bandit. So in an exam or in a test, this would be the kind of one you might realize is quite tricky and come back to it a bit later. Okay, so thanks for listening. As always, until next time, see you soon.